Okay, welcome back to Exam 2 review for Math 1813, which is also known as Prep for Calc. So let's just hop right into it. Number 7 states, a sample of rock was found to contain a mixture of minerals, part of which were radioactive and decreasing over time due to radioactive decay. The mass m of the rock in grams after t years is given by m of t equals this function, which is the equation of the horizontal asymptote. So it says sketch a graph to help with this. So let's sketch the graph, right? So let's assume that we didn't have this 15 here, right? If we had this right here, our initial value would be 3.8, right? Which means we would start like somewhere right here. However, because we have that 15, it means our whole graph is shifted up 15 units. So our actual initial value now is 18.8. And we know it's decreasing because not only does it tell us in the graph, but it also is a number between 0 and 1, like what we had talked about in part 1. So B is between 0 and 1, so it's decreasing. Okay, so then if we know that it needs to pass through that point and it's decreasing, it'll look something like this. Now, if you notice, I didn't go all the way down. And the reason for that is because if we were to have been down here, the line will never get past 0, right? But we shifted it up 15 units. So that means our new baseline is 15, right? And it's actually asking us, what is the equation of our horizontal asymptote? So we know our horizontal asymptote is going to be happening right here. The equation for that is just y equals 15. So B asks, what was the initial mass of the rock? This is what we were talking about earlier. So initial mass would be where it crosses the y-intercept, and we talked about that. Originally it would have been 3.8. However, because we're shifting up this 15 units, our new initial is 18.8, which makes our initial mass at 0, 18.8 grams, right? And it does say include units. Don't forget your units, please. Our next question says, what should the mass of the rock eventually approach as time approaches infinity? So it's saying, what should our mass be over time? So this is where our horizontal asymptote comes into play. If we were to follow this, I don't know if I have a laser. Oh, I do. If we were to follow this line, it'll get very, 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 very close to 15, but it'll never touch 15. But it does say eventually approach as time approaches infinity. So the way we can look at that is as limit of our x approaches infinity, or t, our function m of t, oh my gosh, let me redo that. So limit as t approaches infinity, so as time approaches infinity, of our function m of t is going to be 15. So the mass of our rock eventually should be 15 grams. Now let's move on to number 8. Number 8 says, assume f is an exponential function f of x equals a b x plus k, where b is greater than 1, a is negative, and k is a real number. Is the graph increasing or decreasing? Concave up or concave down? So let's start with what we know. We know b is greater than 1, but we also know a is negative. So what does that mean? Let's start by just plotting a random graph, right? If our a was positive, we'd have something along the lines of this, right? Because we know, oh, I lied. B is greater than 1, so we're actually increasing. So we're going to look something like this. Oh, right? So it's an increasing graph. We have a positive A right here. However, our real A, and I'll make this in yellow because I highlighted that in yellow, our real A is actually negative. So something like this, which means our graph has just been reflected over the x-axis here. So our graph actually looks something like this. Does that make sense? So this is actually our f of x graph. Equals a b x plus k, where A is negative and B is greater than 1. So now to answer that question, it says, is the graph increasing or decreasing? From what we can tell in our picture here, we can say our graph is decreasing. And then it asks concave up or concave down. So just from the looks of this graph here, it's concave down. And then obviously you can reword that however you want, but that's the general answer. Now we're asked, what are its domain and range? So again, just a reminder, we're looking at this graph, not this black one. This is just if A was positive. What are the domain and range? So let's start with the domain. Domain is our x's, right? So if we look at this, it looks like our x will continue this way forever, and it looks like our x will also continue this way forever, which means it is from negative infinity to positive infinity. Now our range is a little bit different. Our range looks like it will forever go down, but it looks like it has a stopping point as far as going up, and it looks like it's somewhere along this line. And what was this line again? So in our equation, that's actually our k, right? So then when we are to write our range, it is from negative infinity, because it can go all the way down, up to this value k. All right, so now C says, as x approaches negative infinity, what does f of x approach? And then it asks, as x approaches infinity, what does f of x approach? So the way to think about this is, and I'm going to use my laser, as x, so our x is along our horizontal axis, right? As x approaches negative infinity, our y, so we're looking like this, what's happening to our y? As we're approaching negative infinity, it looks like our y has a stopping point, right? It approaches k. So the answer for this one is k. And the way that you can write that is as x approaches negative infinity, comma, as f of x approaches k, right? So that's the way that you can write that in words. So now let's look at this second one. So we're talking about as x approaches positive infinity. So as x approaches positive infinity, it looks like our y is approaching negative infinity. So this is at negative infinity, and the way to write that would be as x approaches infinity, as f of x approaches negative infinity. And those would be your two ways of answering that. All right, now let's go to number 9. Now this is starting a new section, modeling exponential functions. So these are more word problems dealing with these exponential functions. So we're asked to write a formula for each situation. And then just a reminder, y equals a times bx plus k. K is usually 0 unless we are told that there is some constraint, right? Okay. So let's start with 9a. Median home price in the U.S. were about $186,000 at the end of 2008 and fell, that's a key word right there, fell by about 2.5% per year for a few years. Let M be the median home price and T be the number of years since 2008. So what those nice handy-dandy words mean right there, it means that at 2008, it was our initial year, which means it can also give us our initial population, or not population, silly me, our initial price. So let's write our y equals a, b, x plus k. In this case, we were not specified k, so we can just assume 0. We are given an initial a. Like I said earlier, if we were talking about since the year 2000, whatever our price was at the year 2008, that is our initial price. So we know that it should be 186,000, right? And then we do know a B to an extent. So we know that it's decreasing by about 2.5% a year. So that means that from 100%, we are decreasing or subtracting by 2.5%, which is 97.5%. And then as a decimal, this is our B. So B would be 0.975. And then we want our X to be T, and we want our Y to be M. So just to write that a little bit better, M is equal to 186,000 times 0.975 T. And that is our formula for this situation. So let's move on to the next problem. So for B of that number 9, it says Dan had an annual salary of $30,000 when he was hired. And he has had an annual salary increase of 3.2% each year since. So I'm going to highlight this because increase is very important. Let D be Dan's annual salary and T be the number of years. So we had an annual salary, right? And it has increased since. So that means that this is actually our initial salary. And then let's remember what they want us to use: D as salary and T number of years. So if we were to plug into Y equals A, B, X plus K is 0 in this case because they don't tell us anything about a K. Y is D. Let me actually make that in black ink. Y is D. We said our initial was 30,000. We said our B, so I'm going to go up here. So it says we're increasing by 3.2% a year. So if we start with 100% and we increase by 3.2%, we're left with 103.2%. And as a decimal, this is B. As a decimal. So that means our B is actually 1.032 to the T because our X in this case is T. So that is our answer. Alrighty, so now number 10 says the population of India was about 1.41 billion people in 2021, and at that time was growing at a rate of about 8.7% per year. Write a formula for the population P of India in billions as a function of T years. So I'm going to highlight a few things. So we know the population was 1.41 billion people in this year of 2021, and it has been growing. Basically, this means since, which means we can assume that this is our initial condition per year, and it is growing. So I'm going to highlight that, growing at a rate of. So we're asked to write a formula for the population P in billions as a function of T years since 2021. So we know this is our initial time. So let's start with our general function plus K. Again, we're not given a K, so we're just assume that's 0. Our Y is actually P. Our A is the initial condition, so we want it in billions, so we're just going to leave that as 1.41. And then we want our B, and we know we're increasing, so I'm going to do this off to the side. 100% plus this 8.7% increase a year gives you 108.7%. So that means our B as a decimal is 1.087 to the T power, because that is the variable we were asked to use. So that is our answer for that one. So now it says, if the growth rate stays constant, predict the population of India in the year 2024. All that means is, assuming what we assumed in A, what will the population be in the year 2024? So that means we can still use our formula we came up with of this, right? And we want the year of 2024, right? So T is years since 2021. So if we wanted to find that difference, we would subtract them and get 3. So this is actually our T. So we want to know our population 3 years after 2021, which is 1.81 billion people. Right, because we just said that whatever number we get is just in billions. All right, C says, by what percent did the population of India increase in the 2-year period between 2021 and 2023? So this one's a little weird. We have to do 2 steps. So we first have to do what we did in B, where we have to find the population in the year 2023. And it does tell you that it's a 2-year period, so we know we're going to be solving for P when T is 2, right? So then P at that stage will be 1.67 billion. And we know we started with P initial was 1.41 billion. Okay. And I'm going to change this because this was actually in the calculator 1.666 billion. So that's what actually I will use to solve for the percent increase. So in order to find percent increase, you're going to find the difference. So the amount of change over your original amount. So that will look something like 1.666 minus 1.41 all over 1.41. And that will give us, oh, and this actually has to be multiplied by 100% to get a percentage, right? So this will get us 0.1816. Turn that to a percent by multiplying by 100%. So that means we have an 18.16% increase. Awesome. Okay. Number 11 states, an investment decreases in value by 5.3% in each year for 3 years. So 5.3% each year for 3 years. By what percentage does the investment decrease over the 3-year period? And so the way to do this is actually a little, not strange, but it's more conceptual. So if we think about how we worked the last problem, and let me do this with blue so it's a little different. If we have y equals a b to the t, and we know there's no k because we don't have any, initial condition like that. So we know that this actually looks something like y equals some initial value times this decrease. So 100% minus 5.3% will give us 94.7%, which is essentially b as a decimal would be 0.947, and this is per year, right? So our initial value in this case is a, right? That's just known. Now, if we wanted to find our y new, or our new, let me use a different letter. Let me use maybe, if we're talking about investment, so I'll just call it y new. I don't really want to have to try and come up with something. So y new still equal to our a, still the same rate of decrease, but this time our t is actually 3 years. So it's just like what we did up here, right? So we still want our percent decrease essentially. So amount of change, and what this entails over original, our amount of change would be from our initial value to our new value. So from our y new minus our initial value over our initial value. And then all of that times 100%, because we are looking for a percent decrease, right? So if we know our y new is this a times 0.947 cubed, minus we know our initial was just a over our original was just a. Each of these has an a, so we can actually get rid of a's here, which makes our whole thing turn into 0.947 cubed minus 1. Seems simple enough, right? And then all of that needs to be multiplied by 100% to make it a percentage. So if we put that into the calculator, 0.947 cubed minus 1 gives us 100%. Oh, and just a reminder, this is the absolute value. So this is the absolute value, which means this is the absolute value, and this is the absolute value. Because you get a negative number here, but it's actually supposed to be the positive of it. Of 0.1507. And as a percentage, move the decimal over 2 places, we have a 15.07% decrease. Alrighty, and now number 12. Suppose a population of ants in a colony grows at a continuous rate of 6.2% per month, right? The initial population is 200,000. So this is our initial. Write a formula for population P of a colony of T months. So we know P and we know T. This formula does not look... Okay, let me backtrack. When it says continuous, it means you're probably going to be working with an E to the KT, right? And again, just like with the Y equals ABT, this BT and EKT is very similar. It's a rate of change, but K just deals with continuous change, right? So our formula base actually looks like Y equals A E to the KT. So then we know Y has to be P. We know our A is 200,000 because that's our initial. E is just a value, so we keep that there. K we were given as 6.2%, so that's just 0.062. And then T is our time in months, so that's just T right there. And that is our answer. So unlike our B where we had to either subtract it from 100 or add it to 100, our K is just the number we're given. And that is only if it says a continuous rate. So now we are asked, what is the monthly percentage growth rate? So in order to find this, there's just a few things I gotta cover. So when we're talking about percentage growth rate, we're referring to R, right? And if we backtrack, R is usually what's given in the last problems. And if you remember, in order to find B, we either did 100 plus or minus, right? But I'm gonna make this just 1 plus R, right? And this is just R is our percent growth rate, and then B is our basically rate that we use in our equation, right? Now, if we look at the continuous rate, we have something like EK to the T. So, fun fact, EKT is equal to B to the T, right? Which means that EK is equal to B. Which means that EK is actually equal to 1 plus R. And what we're looking for in this case is R. That's what we're being asked for. So if we know E to the 0.062 has to equal 1 plus R, in order to get R, that'd be R equals E 0.062 minus 1, right? Did I just move stuff around? Oh, I just move this here and move this here. So then if we were to solve that, just plug it into our calculator, E to the 0.062 minus, let me write that down. So that's 1.0640 minus 1. R is just 0.0640. And we want it as a percentage, so that means R as a percentage is 6.40%. Alrighty, so that's that for part 2 of the exam review for Math 1813. Stay tuned for part 3.